In previous videos, we have looked at trig functions of special acute angles, applying the work with our right triangle trig on right triangles that have two angles of 45 degrees each, so a 45-45 right triangle, and then a 30-60 right triangle. So we found the six trigonometric functions of the 30-degree angle, the 60-degree angle, and the 45-degree angle. Now, if you want to go back and if you don't remember specifically what those ratios were, you can go back and review that video. I've listed them up here for our reference, but again, if it's something where you're not remembering exactly how we developed those, certainly go back and look at the video on the trigonometric functions of special acute angles in degrees, and all of these will be developed. Now, the other thing I want to mention is in an earlier video, we looked at as well the radian measure of an angle. And we looked at the idea that if you take and go all the way around the circle with degree measurements, the total degree measurement of that central angle for an entire circle is 360 degrees. The definition of a radian is the length of a radius of a circle. So we saw that if we took the length of the radius of a circle around the outside edge of the circle, then one radian measure along the outside edge of the circle, and looking back at the central angle that cuts it, that central angle has a measure of 1 radian. If you just took half the measure of the radius for that circle and went back to the central angle, that central angle would have a measure of 1/2 radian. When we want to tell people that we are looking at an angle in degrees, the notation is to put the degree mark on. If we're trying to portray symbolically to someone that our measure of our angle is in radians, you just write the numerical value without the degree mark. So it's really, really important that if you have an angle in degrees, you put the degree mark on there, and if it's an angle in radians, that you don't put the degree mark on there. It's also very important to realize that if you have a number that doesn't have the degree mark on it, that is an angle measurement in radians. So if you have an angle measurement and it doesn't have the degree mark on it, it's in radians, whether there's a pi with it or not. Now, the other thing that we saw from geometry is that the circumference of the circle, so starting at the beginning and then going all the way around and coming back to where we started, that outside distance around a circle circumference has the formula that the circumference is equal to 2 pi r, 2 pi times the radius. Well, if I'm looking at an angle measurement in radians, then going all the way around the circle gives me 2 pi radians. If I go halfway around the circle, I have 180 degrees, or I have half of 2 pi, which is pi radians. So we had that equivalency that pi radians is equal to 180 degrees. Now, with these special angles, we want to not only know them with the degree measurement, we also want to know them with the radian measurement. So what we're going to do next for this video is we're going to look at, well, what is the radian measurement that goes along with each of these special angles, and write out what we have for the trig functions of those special angles. Okay, so first for our 30 degrees. So if I have 30 degrees, and I want to change that to radians, remember we put that over 1, and we multiply by the conversion factor where it's in degrees now, and I want to go into radians. The degrees are in the numerator, so to get degrees to cancel, I have to put degrees in the denominator. So I'm going to have my 180 degrees in the denominator, and its equivalency in radians of pi in the numerator. So then that gives me common factors that we'll remove, and 30 degrees goes into 180 degrees 6 times. So I have pi over 6 is equal to 30 degrees. That means that when I come back to these definitions of our trig functions of those special angles, well, since 30 degrees is the same angle as a radian measure of pi over 6, then the sine of pi over 6 is going to be the same as the sine of 30 degrees. So it's going to be our 1/2. The cosine of pi over 6 is the same as the cosine of 30 degrees. So that'll be the square root of 3 over 2. The tangent of pi over 6 is the same as the tangent of 30 degrees, which is the square root of 3 over 3. And going the rest of the way down, the different trig functions along this for the 30 degrees, we get our special angle of 30 degrees is going to be a radian measure of pi over 6. So the 6 trig functions of pi over 6 are listed here along with our table. Okay, now let's look at what about the 60-degree angle. Well, for the 60-degree angle, we're going to come back and we've got our 60 degrees. We want to change it to radians. So we're going to go 60 degrees over 1. We're going to multiply by the conversion factor of pi over 180 degrees. And when you take 60 degrees times pi divided by 180 degrees, and you remove that common factor pair of 60 degrees in the numerator and the denominator, we get that that's the same as pi over 3. So now the sine of pi over 3 is the same as the sine of 60 degrees. So that is square root of 3 over 2. The cosine of pi over 3 is the same as the cosine of 60 degrees, which is 1/2. The tangent of pi over 3 is the same as the tangent of 60 degrees, so that's the square root of 3. The cosecant of pi over 3 is the same as the cosecant of 60 degrees, which is 2 times the square root of 3 over 3. And then the rest of the way down, the different trig functions of that pi over 3 angle, which is also the 60-degree angle. Now, one thing I want to mention here before going on to our last set of trig functions of the 45-degree angle is that when you're doing this, you don't want to just straight memorize stuff without trying to tag some meaning to it. If you try to do it that way, it all just gets all messed up. The main thing you want to do is think, okay, why does this make sense? What part of this can I say, yeah, that would be reasonable, that is the way it would go? Well, one of the things you can do when you're thinking about these nice angles is, you know, for degrees, it's going to be 30 degrees, 60 degrees, or 45 degrees when we're looking at these beginning ones before we get into like what happens if you go all the way around the circle. So just right there in the first quadrant, just right with our right triangle trig of our acute angles that are the special angles. So I've got 30, 60, 45. Now with the radians, we saw so far that our 30-degree was an equivalent radian measure of pi over 6, and our 60-degree was an equivalent radian measure of pi over 3. So I'm thinking, okay, I'm going to think pi over 6 or pi over 3. But think about just the measurement. A 30-degree angle is smaller than a 60-degree angle. And a 1/6 of a pi is smaller than a 1/3 of a pi. So it makes sense that the 30-degree angle goes with the pi over 6 and that the 60 degrees goes with the pi over 3. Then I just have to do the 6 trig functions of the special angles from the definitions. So it does make sense that that would be how the connection would hold up. Now the last one we have for our special angles is the 45 degrees. Well, if we take 45 degrees multiply by the conversion factor, so the degrees go out and the radians come in. We'll have our 180 degrees in the denominator, our pi in the numerator, and the common factor 45 degrees exists between the numerator and the denominator. And when you remove that common factor 45 degrees, you get a 4 in the denominator. So I have pi over 4. And again, a fourth is halfway between 0 and pi over 2. Well, a fourth of a pi. So pi over 4 does make sense that it's halfway between 0 and pi over 2. And remember, our pi over 2 is the 90 degrees. Half of 90 degrees is 45 degrees. So it makes sense that 45 degrees goes with pi over 4. So then the sine of pi over 4 is the same as the sine of 45 degrees. So that's the square root of 2 over 2. The cosine of pi over 4 is the same as the cosine of 45 degrees, so that's square root of 2 over 2. The tangent of pi over 4 is the same as the tangent of 45 degrees, which is 1. The cosecant of pi over 4 is the same as the cosecant of 45 degrees, which is the square root of 2. The secant of pi over 4 is the same as the secant of 45 degrees, so that's the square root of 2. And then the cotangent of pi over 4 is the same as the cotangent of 45 degrees, which is 1. So here we have all of those special angles and radians as well as degrees, and then the 6 trigonometric functions of each of those.